Dear students, today we'll discuss this model question paper 2022-23 schemes. Subscribe my channel and like all videos. Maximum this question paper examples already are solved in my YouTube channel, so you can watch from that. Individual videos are there for some maximum topics. This is obtain DFA to accept the string of age and base having odd number of age and even number of base. Odd number start with 1 or 3 ones. Odd number of start with 1A or 3A. 1A or 3A. 1A is accepted or 3A is accepted. Before this A, you can take 2B 1A or 1A 2B. B, then A is accepted, or 1A, then 2B is accepted. B is accepted, or B, AB. This is also odd number of age and even number of base. Thus, A, B, or you can take one more transition here. A. This DFA can accept this string odd number of age and even number of base. Number is Q0, Q1, Q2, and this is Q3. This DFA can accept the string odd number of age and even number of base. Question number 1B. Draw DFA to accept decimal string divisible by 3. Well, this is integer numbers. If integer number is there, then direct we can write. Already one example, this example I have solved in my YouTube channel. You can watch there. That DFA is constructed using 4 state. We can construct using 4 state or 3 state. First, divisible by 3 means x mod 3 equal to, we'll get remainder either 0 or 1 or 2 means 0 mod 3 equal to 0. 1 mod 3 remainder is 1. 2 mod 3 remainder is 2. Then 3 mod 3 remainder is 0. 4 mod 3 remainder is 1. Means we will get remainder either 1 or 2 or 3. If remainder 0 is there, then that is divisible by 3. Then 1 is not divisible by 2 or not divisible by 3, and 3 is not divisible by 3. But total will get remainders will get 0. When will get 0? Number is 3, 0, 3, 6. Will get remainder 1. For this we can assign input symbol A. Then B will get remainder 1. When will get remainder 1? Number is 1, 4, 7. For these numbers we'll get remainder 1. Next we'll get remainder 2. When we'll get remainder 2? 2, 5, 8 up to n. For these numbers we'll get remainder 2. Remainder will get 0 or 1 or 2. Means there are 3 input symbols. If remainder is 0 means that is divisible by 3. You can take initial and final, both are same. If this is divisible by 3, if remainder is 0, means 0, 3, 6. For this number, remainder is 0. This is divisible by 3. If remainder is 1 and remainder is 2. Direct also, direct you can construct DFA without table. Remainder 1. Suppose our digit is only 3. 3 means single digit is there. This is divisible by 3. Alright. Next, suppose integer numbers 1. For this remainder is 1, or for this remainder is 2. If remainder 1 means this is B. or 1 comma 4 comma 7, or remainder 2 when only if number is 2, string is 2, then we'll get remainder 2. Means this is remainder 2, means this is C 5 7 8. We can construct this one. Remainder 2, remainder 1. Remainder 1, then remainder 2, means this is string is 1 2, and this 1 2 is divisible by 3. 1 2 is divisible by 3. This is DFA. DFA means from each state we can take 3 transactions, because our input symbols remainder 0 1 2, means from each state you can take maximum 3 transactions. From this Q0 3 transactions 4. Next remainder 1, then string is 1 2. 1 2 means remainder 1 comma 2, and this is divisible by 3. Means 1, if remainder 2 is there, then again we have to move to final state. Means this is remainder 2. Remainder 2 will get from this C 5 2 5 8 numbers. This is remainder 2. From this one transition is over. Maybe a string is 2 1. Remainder 2, then remainder 1. This is remainder 2. Remainder 2 and remainder 1. Remainder 1 means remainder 1. Remainder 1 2 1. 2 1 is divisible by 3. Remainder 2 and remainder 1. Remainder 2, then remainder 1. Means this is divisible by 3. 1 means this is B. We have shown this is B. Means from this one transition is over, from this one transition is over. Maybe our string is 1 0 2. 1 0 2. 1 0 2. 1 0 2 is divisible by 3. Means remainder is 1 0 2. This is divisible by 3. If this is divisible by 3, then remainder 1. Then 0, already 2 is there. Means from this you can take remainder 0. Means here A. Similarly, string is 201. 201 is divisible by 3. 201 is divisible by 3. For this remainder is 201. Remainder 2, this is remainder 2 and remainder 1 is there. For this remainder 0, we can take self loop. Remainder 0. Remainder 0 means here A. Or from this 2 transition, or from this also 2 transition, or next string may be 1 1 1. Remainder 1 1. Remainder 1. Remainder 1. Remainder 1. And this is divisible by 3. This is divisible by 3. Remainder 1 is there, and here 1 remainder is there. Means we can take one transaction here. If remainder is 1, 1 means B. If remainder 1, then this is transaction from Q0, this is Q1 and Q2. Remainder 1, remainder 1 and remainder 1. This is accepted. Next, this is remainder 2 or remainder 2. And suppose number is 2 2 2. This number is, this string is divisible by 3. And for this remainder is 2 comma 2 comma 2. Means remainder 2. Remainder 2 means this is C. Again remainder 2 and remainder 2. This is divisible by 3. This DFA can accept this string divisible by 3. Next question. Question number A, B. Then question number 3 is, this is theory questions. You can read from textbook. Next question number 2A. Question number 2A. Obtain epsilon NFA. Means we have to design epsilon NFA which accept the string consisting of 0 or more A's followed by 0 or more B's followed by 0 or more C's. Means 0 or more A's followed by 0 or more B's followed by 0 or more C's. Means what is the epsilon NFA for this? 0 or more A's means here self loop. 0 or more A's followed by 0 or more B's. 0 or more B's followed by 0 or more C's. This is final state. Q0 is initial state, Q1 and Q2 is final state. 0 or more A's followed by 0 or more B's followed by 0 or more C's. This is epsilon NF to accept this string. 0 or more A's followed by 0 or more B's followed by 0 or more C's. Next question. Question number 2. 1 is all. Question number 2b is theoretical. Define the PDA. Means define DFA and give example of DFA with transactions. Next question number 2c. Question number 2c. Question number 2c. Obtain DFA for the following. Obtain DFA from the following NFA using lazy evaluation methods. Means what to convert from this epsilon NFA means NFA to DFA. NFA to DFA. How to convert from NFA to DFA? There is simple algorithm is there. Epsilon initial state of NFA is initial state of DFA. All input symbols of NFA are the input symbols of DFA. All transaction of NFA equal to transaction of DFA. Then final state. This is question number 2c. Convert from NFA to DFA. How to convert from NFA to DFA? First, starting state of step 1. Starting state of DFA. Starting state of DFA is the starting state of NFA. NFA means starting state क्या है? Q0. The starting state of DFA is Q0. For this you can assign A. Step 2. What are the input symbols? Input symbols. Summation equal to what are the input symbols? 0, 1. There are 2 input symbols. Next, step 3. Find all transactions. Find all transaction on input symbol 0 and 1 from A. Means consider state A on input 0 and 1. Both are to check. Delta D DFA transaction A on input symbol 0 equal to NFA A on 0. What is A? A means Q0. Q0 on 0. Q0 on 0. Q0. Q0 on 0. Q0. Q1. Q0 and Q1. Assign this as A is or assign this as new state. Means this is B. Similarly, A on 1. A on 1. A on input symbol 1. A on 1. Means A means Q0. Q0 on 1. Q0 on 1 only one state is there. That is Q1. And this is new Q0. Q0, Q1. This is Q1. Means assign this is new state. This is A, B, and this is C. A is OR. And we got new state B and C. Similarly, we check B and C. Step 4. Now, within this step 3, substate. This is consider state B on input 0 and 1. B on 0. What is B? You can write separate. Q0, Q1 on 0. Q0. Q0 on 0. Q0 on 0. Q0, Q1. And Q1 on 0. Q2. Means here you can write Q0, Q1 and Q2. This is new state. Assign this is C. And C is on. This is D. Next, similarly, B on input symbol 1 means delta n Q0 Q1 on input symbol 1 Q0 on 1 Q2 Q1 on 1 Q2 means this is Q1 and Q2 and Q1 and Q2 is again new. This is Q0 and Q1 and Q2 means this is new state. Assign this as A. A is or B is or consider state C on input symbol A and B. On input symbol both A and B. C on 0 and NFA, transition of NFA. What is C? C is Q1 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 on 0 Q1 on 0 Q1 on 0 Q1 on 0 Q2 and this is Q2. Q2 is there within this? No, this is new state. Assign this as capital F. Next this is 0 then 1 C on 1 same as Q1 on 1 Q1 on 1 Q1 on 1 Q2. Next state is Q2. This is repeated. For this you can assign F. C is over. Then consider state D. D on input symbol 0 and 1. D on input 0 and 1. What is D? D on 0. NFA transaction D. D means Q0, Q1, Q2 on 0. You can write separate or you can write direct. Q0 on 0, Q0 on 0, Q0, Q1, Q1 on 0, Q2 on 0, 5. Means this is Q0, Q1, Q2 and this is repeated state. Means this is D. 0 is over. Then D on 1. D on 1 NFA transactions Q0, Q1 and Q2 on input symbol 1. Q0 on 1 Q1, Q1 on 1 Q2, Q2 on 1 Q2 means Q1 and Q2. Q1 and Q2. Q1 and Q2 already repeated. This is E. D is over. Similarly, I can write again. Consider state D is over. Consider state E. Input 0 and 1. What is E? E 1, 2. Q1, Q2 means E on 0 NFA transition. What is E? Q1, Q2 on 0. Q1 on 0, Q2 and Q2 on 0, 5. Means this is Q2. For this Q2 we assign F. Next E on 1. E on 1 Q1 and Q2 on 1. Q1 on 1 Q1 on 1 Q2 Q2 on 1 Q2 means this is Q2. This is F. E is over. Last one more is then that is F. Input 0 and 1. What is F? F is Q2. F on 0 F on 0, Q2, Q2 on 0 in NFA, Q2 on 0, Q2 on 0, 5. There is no transactions. F on 1, F on 1, Q2 on 1, Q2 on 1, Q2. This is F. All states over, then stop. So check here. This is starting state. Step 1, identify starting state, then identify input symbol and all transactions from starting state A on all input symbol, on all input symbols. We got new states A, B, C, D, E, F. 4 step, identify initial and final step. Step 4, what is A? A equal to only Q0 and B equal to Q0 and Q1. Q0 and Q1. C equal to only Q1 and D equal to, where is D? D equal to Q0, Q1, Q2. Q0, Q1 and Q2. E equal to Q1 and Q2. Q1 and Q2. Then F equal to only Q2. And within given NFA, which is initial state, Q0 is initial state, and which is final state, Q2 is final state. In any DFA, initial state is only one and one or more final state. Here, this is initial state. Initial state, and which is final state? If Q2 is there, means this is final state. This is 1, 2, 3. These 3 are final state. These 3 are final state. And once you know initial state, final state, and all transactions, then you can construct transaction table. And transaction table, our input symbols, there are 2 input symbols, 0 and 1. And which is starting state? A. You can consider the states A. A on input symbol A. Yeah. A. A on 0 B. A on 1 C. But this is B C. New state B. B on 0 D. B on 1 E. B E. B is over, then C. C on 0 F F. C on 0 F. C on 1 F. Then D. D on 0 D. D on 1 E. D on 0 D. Then E. And D is final state here. D is final state. Final state can be represented with star. D. Then next state is E. E on 0. E on 0 F. And E on 1 F. E on 0 and 1. That is F. F. And last F. E is final state and F is final state. F on 0 5, F on 1, this is 5 F. And once we know transaction table, then we can construct DFF from this. And DFF from this, A. From A, B and C, both are intermediate states. On 0, on 1, this is B, C. B on 0. Yeah, B on 0, D and E. This is D and E. D and E. D and E both are final states. D and E both are final state. D on 0 on 1. This is D and E. Then C. F is new state and F is again final state. 0, 1. Next D. D to D self loop. D to D self loop on 0. D to E on 1. E to F 0, 1. And F to F on 1. This is DFA from epsilon NFA. And then this is DFA from NFA. Next question. This 2C is OR. Next question. 2C. Then question number 3A. 3A is questions. This is theory questions. And question number 3B. Question number 3B. Question number 3B and 3C both are numericals. Question number 3B. Obtain epsilon NFA. Obtain epsilon NFA for the regular expression. Regular expression is given. From this regular expression, we have to construct epsilon NFA. Epsilon NFA for this. First, A plus B bracket to the power star. This is A, B, epsilon. Before this, you can add one more state because this is bracket to the power start. This is epsilon and this is also epsilon. State number is, you can give anything. This is 0, 1, 2, 3, 4, 5, 6, 7. Then two transition on A and B. A, B, B. B, B. 1B, then second B. 8, 9. Then again A plus B bracket to the power star. This example also already solved in my YouTube channels. You can watch from there also. This is A, B, epsilon. For this we can add one more, that is final state, epsilon. This is one transaction using epsilon and another transaction from this state, epsilon. This is 9, 10, 11, 12, 13, 14, 15, 16. This is epsilon NFA from the regular expression. Next question is question number 3C. Question number 3C. This is minimize the DFA. Minimize the following DFA. This DFA is given in table format. Means this DFA you can solve using table filling algorithm. And this questions already I have solved in my YouTube channel. You can watch from there. This one questions you can watch from my YouTube channel. Next, pumping lemma. In pumping lemma, this theorem also I have given in my YouTube channels. You can watch from there. This pumping lemma is theory questions, and this language a to the power n, a to the power I, b to the power j, I is greater than j. I is greater than j means this example, within this example, from this language generate this string. This pumping lemma example you can solve in 3 steps. This theory example pumping lemma theorem you can watch from my video channels. This example, from this X, from the given language generate the string. Which string can generate from this? A to the power I, B to the power J, I is greater than J, means number of H is greater than J. Here 3A 2B means A is greater than B. Step 1, first identify the string. Step 2, split this string into 3 subgroups. X is divided into 3 subgroups. This is U, V, and this is W. But X is equal to U, V, W, V to the power I. V to the power I. If I equal to 0, I equal to 0 means V will not be appear. And V will not be appear means X is equal to U and W. U and W means A to B. And this condition is valid. Here A is greater than B, but here B is greater than A. Means this is called as, using this you can prove the given language is not regular language. Next. Next question. Develop a regular expression. This question number 4b. Develop a regular expression for the following language on input symbol A and B. Means from this two input symbols you have to generate the regular expression. अब condition क्या है इसके ऊपर? Accept string of A's and B's means हमको क्या है? A and B से regular expression है. Whose fifth symbol from right hand. Whose fifth symbol from right hand is A. From right hand fifth symbol 1, 2, 3, 4. Fifth symbol is A. And before this you can take anything. Means here A or B, A or B, A or B, E or B. And before this you can take any combination. And what is the regular expression for this? A plus B bracket to the power star A plus B, A plus B, A plus B, A plus B. This is fifth symbol from right hand is A. Regular expressions we have to write in single line. For this single line we will get, yes, this question has for 6 marks. 2 questions means for the single line we will get 3 marks. Next, accept string of A's and B's containing not more than 3 A's. यहाँ पे क्या बोल रहे हैं? मैक्सिमम हमारे पास कितना 3 A's रहना है. 3 A's, मैक्सिमम 3 A's. A or epsilon, A or epsilon, A or epsilon, right? Maximum कितना 3 है. Between this we can take any combination. Between these two we can take any number of B's, or between this we can take any number of B's, or after this you can take any number of B's, or before this you can take any number of B's. This is regular expression from A's and B's, not more than 3 A's. Maximum 3 A's होना चाहिए. Next, question number 4C. What is question number 4C? Question number 4A is theory questions. Question number 4B is regular expression. And question number 4C. Question number 4C is find regular language accepted by the following finite automata by eliminating state. From this we have to find regular expression using state elimination method. We can convert this into 2 types, but here this is clearly mentioned using state elimination method. In state elimination method, first find is there any dead state? If yes, first eliminate the dead state. Within this, which is dead state? Q2. Q2 is reachable from the starting state, but from Q2 to final state there is no transaction. Means Q2 is dead state. Then eliminate Q2 and all adjacent edges. After eliminated Q2, this is Q1, Q0, Q0 and Q1. Q1 and Q1 both are final state. In state elimination method, we cannot eliminate initial state as well as final state. Both are final state. We cannot eliminate. Now, what is the regular expression for this? यहाँ पे ए बी फाइनल स्टेट है और ए बी फाइनल स्टेट है, बस हम यहीं पे रुक सकते हैं और यहाँ से आगे भी जा सकते हैं. बस व्हाट इज द रेगुलर एक्सप्रेशन फॉर दिस? 0 स्टार एनी नंबर ऑफ zeros or any number of zeros 1, then any number of 1 star, and from this you can take any common. From this you can take 0 star common. After this 0 star, here nothing is there, means epsilon plus 1 plus star. This example is also already solved in my YouTube channel. You can watch from there. This example, this one we can reduce. Here epsilon plus 1 to the power star. 1 to the power star can generate 1 or 1. This can generate 1 or 1 to the power star. 1 to the power star can generate 1 or any number of 1. 1 to the power star can generate epsilon. For this again we can write 1 to the power star. Regular expression for this 0 star 1 star. Next question. State elimination method is over. This example is over. Next, what is an ambiguous? Explain the technique to reduce the ambiguous grammar. This is theory questions. You can write definition and reduce ambiguous grammar. Next, this question number 5b. Show that the following grammar is ambiguous by taking string is given. यहाँ पे क्या है? String दिए सो है, grammar दिए सो है. Only what to prove the given grammar is ambiguous grammar. This example also already I have solved in my YouTube channel. You can watch from there also. Show that the following grammar is ambiguous by taking string is given. तो हमको क्या करना है? ये string लेके हमको prove करना है given grammar is ambiguous grammar. This is very simple example. Derivation, yes, produce. Here you can write derivation symbol. One time you take first production, another time you can take second production. Using different production, you can prove the given grammar is ambiguous for same string. AS, this yes replace with second production. AS, BS, yes produce epsilon means BS. Again, yes produce epsilon means AA, B. String is generated. And tree for this, yes produce AS, and this yes produce AS, BS, yes produce epsilon, this yes produce epsilon. This is one derivation. Second derivation, yes produce second production AS, BS. This terminal as it is, yes replace with first production AS, BS as it is. Then AA, yes produce epsilon means BS. The second B produce yes produce epsilon means AA, B. And tree for this AS, BS, and this yes produce AS, yes produce epsilon, and this yes produce epsilon. By applying two different derivations for same string, if you got two different trees, means this grammar is ambiguous. This given grammar is ambiguous. Next question number 5C. Question number 5C. Design a CFG grammar, context-free grammar for the language. Language is given. There are two languages is given. Design CFG for the language. Language is given to accept the set of strings with no more than 3 years. With no more than 3 years. Already one exam, regular expression was seen similar to this. No more than 3 years. Maximum हमारे पास कितने ये चाहिए? Only 3 years. There is no restriction on B. For this we can write simple production. Yes produce. कितने ये चाहिए हमारे पास? 1, 2, 3. Maximum 3 years. Before this, between these two, or between these two, or after this, you can take any number of B's. B. And within this, what is A? A produce A or epsilon. A or epsilon. And what is B? B produce any number of B's. B or epsilon. This is simple grammar from A's and B's. No more than 3 A's. No more than 3 A's. There is no restriction on number of B's. This can generate any number of B's. Next क्या है? To accept set of strings with any number of A's and B's with at least 1 A. With at least 1 A. Yes produce AS any number of A's, BS any number of B's with at least 1 A. At least S can produce 1 A or more than this, any number of A's and number of B's. This can generate at least 1 A. Question number 6. For the below grammar, obtain corresponding PDA. This next example is convert from CFG to PDA. Convert from CFG to PDA. And how to convert from CFG to PDA? There is a simple 4-step algorithm. Using that 4-step algorithm, we can convert from CFG to PDA. CFG to PDA. First term क्या? First up, check. If given grammar is in GNF, this is terminal. With this grammar in GNF. First step, given grammar in GNF. If given grammar in GNF, then move for second step. Given grammar in GNF means the same production. You can write one more time. A, B, C. Then A produce A, B or A. B produce B, A or B, and C produce A. Step 2. Push starting symbol yes into the stack without any input symbol. Push starting symbol yes into the stack without any input symbol. Without any input symbol, and take transaction from Q0 to new state. Means transaction for this Q0 epsilon Z0 equal to Q1 yes Z0. Here starting state is yes. Push yes into the stack. Step 3. Convert grammar into PDA. GNF grammar is in the form of A produce A, B, C or ए प्रोड्यूस ए। अब इसको हम क्या करते हैं, डायरेक्ट ट्रांजेक्शन में करते हैं। मस्ट हियर गिवन प्रोडक्शन, एस प्रोड्यूस ए बी सी, देन ए प्रोड्यूस ए बी, और ए प्रोड्यूस ए, बी प्रोड्यूस बी ए, B produce B, and C produce A. PDA transition, and here all transition from Q1 to Q1. Present, current we are on Q1. Thus Q1 input symbol A, produce symbol S equal to next it Q1, and here A, B, C next variables. Second Q1 input symbol A, produce symbol A equal to Q1 next symbol B. Q1 input symbol A, produce symbol A equal to next state Q1 and epsilon. Q1 input symbol B, produce symbol B, next state Q1 A. Q1 input symbol B, produce symbol B, Q1 nothing is there, miss epsilon. Last input symbol A, produce symbol C equal to Q1. After that next symbol nothing is there, miss. This is step 3. Step 4, finally move to final state. Finally move to final state without any input symbol. Finally move to final state without any input symbol means transaction delta Q1 epsilon Z0 equal to Q2 Z0. And at the last explain all PDA to 7 tuples. This is starting state, the next transaction, and last state. This is question number 6th A. Question number 6th A. Obtain PDF from the CFG. This is simple example. Easily you can score marks here. The next again, let grammar G. Grammar is given. For the string is given from this derivation tree, leftmost, rightmost derivation. You are right. Question number 6th B. This is question number 6th B. From this 6th B, we can write derivations, LMD, RMD, leftmost derivation, rightmost derivation, then derivation tree. This is leftmost derivation. In leftmost derivation, every time replace left side variable. Means yes produce AB, this A as it is. Again B replace with B production, means A B B. A as it is, B. This B replace with B. B replace with terminal B and B. A B. B replace with BS. B replace with BS. B yes. Two A 2B. Again yes replace with first production. Yes replace with A B. A B B, then A. Next again B replace with BS. B yes. A B B A B. Again yes replace with, next we need AB. yes replaced with again A, B, and B replaced with B. This is LMD. And RMD, yes produce A, B, A, this A, B replaced with A, B, B, and this is right side. This B replaced with BS. A, first B as it is, B, yes. B as it is, this terminal B as it is, again yes replaced with AB, A, B. Again B replaced with B, S. B replaced with B, yes. Again yes replaced with first production. A, B. B produce B. This B produce B. Then this B produce B. Two A, 2B, AB, AB. The string is jumped. LMD, RMD. Then tree for this. For LMD and RMD, we will get tree same. Yes produce A, B. Then again B replaced with A, B, B. This B produce B. This B produce B, yes. Again this is A, B. Again B produce B, yes. And yes produce A, B, B produce B. 2A, 2B, AB, AB. This string is generated. This is LMD, RMD, then derivation. Derivation tree or parse tree. This is question number 6B. Question number 6C. Define CFG. Definitions you can write. In a CFG grammar, left hand side of the production, only one symbol. That symbol must be variable. Such production is called as CFG. Design CFG for the language. Question number 1 is given 3 questions. Question number 1C. 1, 2, 3. 3 questions. Each question carry for 3 marks. यहाँ पे consisting set of non-palindrome or input symbol A and B. Non-palindrome numbers बोल रहा है, right? Non-palindrome number means yes produce AS A or BS B or A. Here you can take new variable A B or B A. Then what is A? A produce AA or BA or epsilon. This is palindrome. यहाँ से जो भी string generate करते हैं, from left and right we cannot read. That is non-palindrome number. Next क्या है? 0 to the power n, 1 to the power n. N is greater than or equal to 1. If n equal to 0, means epsilon, right? If n equal to 0 means epsilon means here. If n equal to 0, then 0 epsilon 1 1. And if n equal to 2 means 1 0 2 1, right? As from this generate the grammar. Yes produce 0, yes 1 or 1. At least 1 1. Next WWR. The WR is given. WR is reverse of W. And grammar for this. Yes produce A S A or B S B or C. Finally, this can terminate using, अब यहाँ पे string क्या है? A B C B A. This is W or this is W. Finally, this can terminate using intermediate symbol C. I mean, this is grammar for W W R. This is question number 6 C. Question number 7. Question number 7 is remove. Question number 7. Remove all epsilon productions and unit production from the grammar. Question number 7A. This definitions are given in my YouTube channel. You can watch from there. CNF and GNF definitions. These definitions are important for external exam. Let's check this definition asked for 2 times. Define GNF and here also define GNF. Here remove all epsilon production then unit production. Means first eliminate epsilon production. After eliminated epsilon we will get resulting production. From that resulting production eliminate unit production. This question asked for 6 marks. This question is very simple. Here remove epsilon production and nullable unit production. First find nullable variables. Nullable variable means which variable can produce epsilon. Here nullable variables, A produce epsilon. Using A, is there another variable can produce epsilon? No. Means nullable variable only A. And once we know nullable variable, then we can write resulting grammar. Resulting grammar means after eliminated epsilon. Yes produce A, and if A produce epsilon means A. And B is nullable variable? No. A, B, B as it is. Then A produce A. If any one A produce epsilon means A. Or both A produce epsilon means A. Next, B produce B, B. B is nullable variable? No. Then B, B, C. This is as it is. Next, C produce B. B is nullable variable? No. This is this grammar after eliminated epsilon. Then eliminate unit production. Unit production, from right hand side of the production only one symbol. That symbol must be variable. Here only one unit production is there. Identify unit production. Unit production is C produce B. My dependency graph for this C and B. C can produce all production of C and all production of D, but C cannot produce anything. Means B produce BC or BBC. And after eliminated unit production, here only C produce B. Means C can produce all production of B. Only one unit production is there. Remaining all are same. Means yes produce A, AR, A, B, and A produce AAR, A, B produce B, or BB, and C produce all B production. C produce all production of B production. B, C, or BB, C. This is after eliminated unit production. After this, you can explain 5 tuples and the 4 tuples. Question number 7B. After 7B, next question number 7B is over. Question number 7C. What is GNF? Convert the following grammar into GNF. What is GNF and कन्वर्ट द फॉलोइंग ग्रामर इनटू GNF. अब हमको क्या करना है, इसको GNF में कन्वर्ट करना है. GNF means right hand side of the progression starting with terminal followed by 0 or more variables. Definition of GNF: in a CFG grammar, right hand side of the production starting with terminal followed by 0 or more production. Such production is called as GNF. Convert this following grammar into GNF. First we have to convert into GNF, then CNF, then GNF. Before this, here unit production is there. First eliminate unit production. Unit production, A produce B. After eliminated unit production, S produce AB1 or 0, and A produce 0, 0, 1 or all production of B's 1, and B produce 1, A 1. This is after eliminated unit production. Then convert into CNF. Direct we can replace 0 with new variable. We can take B0. Must B0 produce 0 and replace 1 with B1. Must B1 produce 1. Substitute this one. S produce A, B, B1, the 0 as it is. Then A produce B0, B0, A, B1, A, B1, and B produce B1, A, B1, B0 produce 0, B1 produce 1. Right. Again, within this non-CNF, this is 1, 2, AB, and a B0, B0, and within this, for these 3, we can assign again new variables. Means we can again replace AB with D0. D0 produce AB. D0 produce AB. Next, replace B0, B0 with D1. Means D1 produce B0, B0. Again, replace B1A with D2. D2 produce B1A. How to replace this? After replacement, after substitution, we will get S produce AB, means D0, B1, 0, and A produce B0, B0, means D0, 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 B0, B0 means B0, B0. B0, B0 is replaced with D1. D1 A and B1A, that is D2. D2 B1. B produce D2 B1. B0 produce 0. B1 produce 1. D0 produce AB. D1 produce B0, B0. D2 produce B1A. V2 produce B1 A. This is in CNF. The CNF grammar convert into GNF. On how to convert this grammar into GNF? Replace all variables. Replace all variables with A of 0 to A of n. यहाँ पे क्या है? Replace all variables. S equal to A0. S equal to A0. A equal to A1. B equal to A2. B0 equal to A3. B1 equal to A4. D0 equal to A5. D1 equal to A6 and D2 equal to A7. Then substitute within this. A0 produce here A0. A0 yes means A0. D0 means A5. A5 B1 means A4. A4 then 0 as it is. A1 produce D1 means A6 D1 A means A1 and D2 means A7 B1 means A4. A2 produce A7 A4. A3 produce A3. B0 means A3 produce 0. A4 produce 1. Next A5 produce A5 produce AB. A means A1 A2. Then A6 produce B0 means A3 A2. Then A7 produce A7 means D2 produce B1 A means A4 A1. Now this grammar convert into GNF. अब यहाँ पे GNF में starting symbol variable होना. This is only A3 and A4 in GNF. This side you can write if A3 and A4 in GNF. If A3 and A4 in GNF, it's okay. यहाँ तो A3 है, A4 है. Means we can convert A6 and A7 in GNF. We can convert A3 and A4 in GNF. Means A6 produce A3 means 0 A2 and A7 produce A4 means 0 1 A1. A6 and A7 in GNF is A6 and A7 in GNF. Then we can convert A6 A7 A1 and A2 in GNF. If A6 and A7 in GNF, then we can convert this A1 and A2 in GNF. A1 कैसा आता है? A1 produce A6 productions, this one 0 A2 A1 and A7 1 A1 A4 and next A2 produce A7 का प्रोडक्शन क्या है? 1 A1 then A4. Must A2 and A1 in GNF. If A2 and A1 in GNF here, then A5 you can convert into GNF. if A1 in GNF, then we can convert A5 in GNF. A5 produce A1. A1 के प्रोडक्शंस क्या है? Here 0, A2, A1, 1, A1, A4. Then this is A2. Let's substitute this one. A5 produce 0, A2, A1, A2 are 1, A1, A4, A2. And if A5 in GNF, then you can convert A0 in GNF. If A5 in GNF, then you can convert A0 in GNF. A0 means A5 productions. A5 क्या है? 0, A2, A1, A2 are 1, A1, A4, A2. Then this is A4. The 0 as it is. Means A0 produce 0, A2, A1, A2, A4, and this 1, A1, A4, A2, A4 are 0. Must following now this grammar in GNF, then explain 5 tuples. भाई क्या कौन सा मिला हमारे को? This one A0 in GNF, A1 in GNF, A2 in GNF, then A3, A4, A5, A6, A7 all are in GNF. Then explain 5 tuples. This is GNF portion. Convert into GNF. Next example. This example converted into GNF. This example asks for 8 marks. Then write LMD, RMD and parse tree for the string plus star minus XY XY. This example already solved in my YouTube channel. You can watch from there. This is a simple example. Write LMD, RMD and parse tree for the string. String is given. String दिए सो only LMD and RMD लिखना है. Then parse tree. Parse tree will get same. LMD derivation E produce first symbol क्या है? Plus. Must unit plus E plus. First E replace with again third production star E previous E as it is. Again from left side E replace with next symbol is minus. Must E replace with third production plus star minus E and this 2E as it is. First E replace with X, then Y, X, Y plus star minus X E plus star minus X Y. Replace at a time only one variable plus minus X Y X E plus star minus X Y X Y. This is called as LMD definitions. And RMD start from right side. RMD derivation E produce plus E plus E. This from right side. This E replace with Y. Then plus this E replace with second production, means third production star E then Y. Again from right side this E replace with X plus star E X Y plus star, then this E replace with minus E this XY as it is plus star E this E replace with Y. Then at the last plus star minus this E replace with X, XY. This is RMD definition. Means LMD derivation, RMD derivation, then parse tree. For you can draw tree for anyone, will get same tree. E produce plus E, then again this you replace with star E, again this you replace with minus E, replace with X, replace with Y, replace with X, replace with Y. This is called as parse tree or derivation tree. This is called as derivation tree. Next, this is 8A, 8B, 8C. Both are examples. Obtain the following grammar in CNF. Let's convert this grammar into CNF. Question number 8B. Convert this grammar into CNF. Convert this grammar into CNF means CNF definition. Right hand side of the process either 2 or 1 symbol. And if you want to convert into CNF means first you have to check left recursive, then upcoming production, unit production, then useless. ये 4 रिमूव करने के बाद हमको CNF करना है. Within this left recursive is there? No. Then epsilon is there. First eliminate epsilon. Find nullable variable. Yes, produce epsilon. Using yes, is there another variable can produce epsilon? No. Nullable variable. Nullable variable. Yes, only one is nullable variable. After eliminated epsilon production, we will get resulting production. Resulting production. Yes, produce ASB. Yes, produce epsilon means AB. Then A produce AA. Yes, and yes, produce epsilon means AA, and terminal A as it is. B produce yes B, yes, yes B or BS or B or A or B after eliminated epsilon. And from this left recursive is not there, epsilon is over, then check unit and useless production. First unit is there, yes, means within this unit production, B produce A, means B can produce all production of B and all production of A. Resulting production after eliminated unit productions, direct we can write yes produce ASB or AB, and A produce AAS or AA or A. Then B produce yes B yes or yes B or BS or B or BB. Then production of AAS or AA or A. This is, and within this is there useless production? Yes, from yes A and B both are reachable. A can terminate, B can terminate, means there are no useless productions. If there are no useless production, then convert this into CNF. First replace A with B0. B0 produce A, and replace B with B1. B1 produce B. After replacement, we'll get S produce ASB or AB, and A produce AS A0, means B0 AS or B0 A or A, and B produce S B1 S B1 B1 S B as it is, B1 B1 B0 AS B0 A and A. B0 produce A, B1 produce B. Next, within this again convert into CNF. This is non-CNF. 1, 2, then 3, 4. These 4 productions are non-CNF. Remaining all are in CNF. Then convert into CNF. How to convert this 3 into CNF? Here AS within this AS is there, and here one variable, means replace AS with D0, means D0 produce AS, and replace S B1 with D2. No, D1 produce S B1. This grammar we can convert into CNF. A produce AS replace with D0, means B0 D0 B0 A or A. B produce D1 S B1 S B B1 B0 AS means D0 B0 A. Then B0 produce A, B1 produce B, D0 produce AS, D1 produce S B1. This grammar in CNF. Right hand side of the process, either 2 or 1 symbol. Such production is called as CNF. हमारा production question क्या था? Convert into CNF. This one. Convert into CNF. Next, define CNF. Convert the following grammar into CNF. Again, this example also convert into CNF. Again, this example asked for 8 marks. Convert into CNF. It's here. Within this next example, this is question number 8C. Define CNF. यहाँ पे इसे दिस क्वेश्चन, यहाँ पे क्वेश्चन पूछा था CNF and GNF, definition of CNF and exam definition with example. यहाँ पे भी definition of GNF है और यहाँ पे भी definition of CNF है. बस इसी क्वेश्चन में 2 बार पूछे से, राइट? Same answer or try 2 times. Next, this question number 8C. Question number 8C. Define CNF and convert this grammar into CNF. Convert this grammar into CNF. Again, replace these variables. This is from this. There is no useless production. There is no unit production. There is no left recursive. No, nothing is there. Means direct we can convert this grammar into CNF. Replace 0 with B0. and replace 1 with b1 प्रोड्यूस 1. हम डायरेक्ट रिप्लेस कर सकते हैं इसमें कुछ प्रॉब्लम नहीं है. यस प्रोड्यूस b0 a b1 b, then a प्रोड्यूस b0 a b1 yes और 1. इसको रिप्लेस नहीं करना. जो ऑलरेडी अगर CNF में है तो उसको एज इट इज रखना. स्टूडेंट यूजुअली यहीं पे मिस्टेक करते. ये 1 को रिप्लेस करते इसको भी करते. इसको नहीं करना है बिकॉज दिस इज ऑलरेडी इन CNF. देन b1 bb b0 yes और 0 as it is. Then b0 produce 0 b1 produce 1. Again from this non-CNF 1 and 2. From this replace again, replace AA with new variable, replace AA with D0 and D0 produce AA and replace BB with D1. Again after substitution we will get yes produce b0 a b1 b, then a produce b0 d0 b1 yes 1 and b produce b1 d1 b0 yes 0 and b0 produce 0 b1 produce 1 d0 produce AA d1 produce BB. This grammar in CNF. Then explain 4 tuples. Grammar 4 tuples. This is grammar in CNF. Question number, this is 8C. The question number 9A is theory questions. You can read. Question number 9 A, B, C, these theory questions. Question number 10 A, B. Question number, these two are again numerical questions. This is a to the power n, b to the power n is greater than or equal to 1, means here 2 variables and here Turing machine 0 and 1 and ending with 0. For this how to construct Turing machines. Next, one more examples. This is question number 10B. Question number 10B, design PDA for the language. Design Turing machine. डिज़ाइन ट्यूरिंग मशीन फॉर द लैंग्वेज. किसका ट्यूरिंग मशीन डिज़ाइन करना है? L इक्वल टू a to the power n, b to the power n, n is greater than or equal to 1. Turing machine for this. And this example already I saw in my YouTube channels. You can watch from my YouTube channel. This is obtain Turing machine from this language. This one example and another one example I have written a to the power n, b to the power n and c to the power n. N is greater than or equal to 1. These two you can watch from YouTube channel. In your exam, you will get A, B or L equal to 0 to the power n, 1 to the power n and 2 to the power n. N is greater than or equal to 1. Maybe you will get like this. Using this these examples, these two examples, you can watch from my YouTube channel. All students, subscribe once again, subscribe my channel and watch all my videos. You can score this subject. इस सब्जेक्ट बहुत सिंपल है. सब्जेक्ट कंफ्यूज नहीं करना. मेरे जितने भी वीडियोस है उतने वीडियोस के चेक किया तो आप वॉच किया तो आपको जो भी पेपर है 100% स्कोर होता है. एंड ऑल द बेस्ट.